you don't know Analog Devices, we are a public company. We make semiconductor components traditionally. We celebrated our 50th year last year. We have about 1,100 people in Ireland, 10,000 people globally. We have our own fab in Limerick that makes some of the sensors that I'll be talking about today. So similar to Mark, I'm going to talk about, I guess, our view of IoT, give you some case studies, and maybe specifically talk around what we need to accelerate IoT, and pick two of those things, and for me it's sensors and security. Do a little bit of a deep dive on those, and then finish up with some case studies. So we talk a lot about bridging the digital and the physical worlds. Our traditional, what made Analog Devices is analog to digital converters. We lead in precision analog to digital converters. And so typically what, like everybody, I guess, we say, well, we've always been in IoT, therefore we're an IoT company. But we're typically sensing the real world, the physical, taking those measurements from sensors that either we have or our customer or our partners have, and then converting that into the digital and passing it up. I think what IoT offers us is a chance to move more into systems, move more up the chain, and similar to Mark, look at things like ROIs to our customers, and again, some of the examples where we're looking at full sensor systems all the way to the cloud. So this is a bit challenging maybe on the eye. I'll maybe flip to the next one. It's a bit easier on the eye, but I mean, again, very similar to Dell, we would have a focus on what we would call high-value, challenging IoT problems in industrial, healthcare, and automotive. Within those, I guess we focused our early efforts on a number of areas. This is 4 of them. So the top left-hand one is remote patient monitoring. So we are looking at developing sensors that monitor the body and predict the onset of the top 5 diseases. I was at a conference last week where one of the top Johnson & Johnson vice presidents of R&D said that in 50 years' time, he believes we won't have those top 5 diseases, and that we'll actually look back and sort of joke about the time when we used to wait until a disease took hold before we treated it. So yeah, a lot of the effort in medicine today in healthcare is around prediction and then intervening so that you can actually potentially put off that disease, whether it be medicine or lifestyle or whatever. So we're doing a lot of work. Today it's heart rate monitoring, but tomorrow it's things like the amount of hydration in a person. You can measure that. If you take an impedance measurement across the body, you can measure hydration, and hydration is typically an early onset indicator of a lot of problems. Building automation, again, we look at sensors around building automation. We have an occupancy detection platform that looks at the occupancy of the people counting and does various things like optimize AC, but also for first responders and emergency case studies. Parking control, again, similar to the building automation. We're using occupancy detection on parking to detect the free parking spaces. So there's a statistic that says 20% of the gasoline in cities is used on people trying to find a parking space. So if you can link the parking spot with the person, then that's a big saving. And then the final one that we've called out here is agriculture. So we're looking at, again, similar in a lot of these cases. I think it's very similar anecdotally. So here it's the human body, here it's the tomato. In a factory example, it's a machine, but basically you're instrumenting that thing to tell more about it, to optimize something down the line in terms of production or health or safety. In this case, so there's an interesting statistic that says farmers, when they're producing tomatoes, a tomato can either go one of two places. It can go to your salad plate, or it can go to your pasta sauce. And there is a factor of 10 difference, roughly 10 cents on the dollar for your pasta sauce, and roughly $1 when it goes into your salad. And a farmer typically doesn't know, he doesn't have any way of figuring out at the end of the process what the tomato is going to, where it's going to go. So we're looking at things like measuring pH, measuring, again, resistance across the tomato, the color of the tomato, to try to give the farmer a way of methodology, trying to figure out what that tomato is going to do. So I guess the title of the talk is Accelerating IoT, and I think there's this concept out there that, well, IoT is here because hardware is commoditized and all the money is going to be made in software. So I guess as a hardware company, we take a little bit of issue with that, and one of the things I want to do in the next few slides is maybe talk a little bit about the challenges as we see them from a hardware perspective. So there's this quote that says, you know, we tend to overestimate the effect of technology in the short run and underestimate the effect in the long run. So all this hype about IoT, while yes, I think we probably are overestimating it in the short run, I think if we fast forward to 5 years and 10 years, I really do think that this is going to really change the game in a lot of industries. And just to talk a bit about, again, how we see the world. So there's, again, this concept out there that says, well, send everything up to the cloud will figure it out, big data will be everything. We believe that there's a lot of use cases where you just simply can't do that. So, I mean, if it's video in the ATM example that Mark had, that takes up a huge amount of bandwidth. And we believe that actually we're going to have to make the nodes very intelligent and put compute in the nodes such that we can make decisions at the edge without having to ship everything back to the cloud. Now, certainly big data is going to play a big part in us figuring out the trends and using that huge database and data sets to figure out, you know, what the triggers are for that edge node. But we also think there's going to need to be a lot more intelligence at the node, which has implications that I'll talk about later. And I guess the other point of this is the partitioning. So ultimately, if you can partition this problem, it's essentially a compute partition problem, whether it be compute at the edge, compute at the gateway that Mark was talking about, or compute in the cloud. For each use case, it's going to have a different optimum, and if you can actually optimize that, you can make the best system. So to talk a little bit about sensors and you know, ADI, we have been doing accelerometer sensors for a long time. We're in things like automotive airbags, but you know, again, I think this concept that, well, you have an accelerometer now in every cell phone, and therefore you can get it for 20 cents on the dollar, and therefore IoT is here and hardware is ubiquitous. I guess our view and my view is that really we have really only scratched the surface of sensing. And if you look at, you know, what we're trying to do in terms of mimic the human body and what we can do, you think about electronic noses, you think about being able to detect volatile organic compounds. I guess it's our view that there's a huge amount of innovation needed, both from us, from our partners, from startups, that isn't there today, and that a lot of these IoT applications in industrial, healthcare, and automotive will only be possible if we can actually get that innovation done and get these sensors at a chip scale level. So in terms of how we look at things, we talk about more than more. So in Limerick, in our fab in Limerick, we actually do a lot of this more than more work, which is to say, okay, there's one element of semiconductor technology where you keep reducing the gate length and you go down. So you hear about 20 nanometers, 7 nanometers. But there's another vector here if you want to bring on sensors, if you want to detect gas and chemicals on a piece of silicon, where you need to bring in different materials, fairly exotic materials, which typically don't work well on a CMOS process. And this is the focus that we're doing internally. We work with partners for the more than more, or for the more, and we work internally to develop this. And we do a lot of this in our fab in Limerick. I'm going to skip quickly through the next slide next few slides because I just got the 5-minute warning. Huge amount of diverging needs in IoT. All the way, if you look here, it's you're going from a smart meter to a smart watch to industrial automation. IoT is not this one market, and a lot of people it's treated in the media or in the hype as an IoT market. I think there is huge divergence in the needs from use case to use case and from market to market. And one of the other big challenges in node electronics is in energy harvesting. So eventually, if we want these things to be autonomous, if we want them to be in the environment, not having to go out and change the battery every year, then we need solutions to energy harvesting that frankly don't exist today. So the picture that I showed earlier on about the compute at the edge, where we want to do more and more compute at the edge, well, that takes more power, and yet today we can't, the amount of power coming out of energy harvesting technologies today can't do what we need to do to transmit back the signal 1 or 0. So again, going back to the original point that there still is a huge amount of innovation and work and investment needed here to get energy harvesting technologies from the microwatts up to the milliwatts, so we can actually run these things autonomously. Just want to mention security. This is a bit of an eye chart. I'm sure you can't really see it. The point of this, I think, is, again, security isn't one thing in one place. Security is many different technologies at various parts of the stack from an IoT perspective. And therefore, I think security is an area where you really need to partner and you need to get the best of breed solutions all the way down to the sensor, to the cloud. For us specifically, we're working on identification of the sensor. So again, coming back to the fact that there is a very limited power budget. You can't really have these 256-bit AES encryptions on a sensor node if you want it to be autonomous and energy harvested. So we're looking at things like physically unclonable devices, where you actually look at the physics of the semiconductor and use that as your encryption key, so you don't then have to store a long encryption key. Just to finish up, and 2 case studies that we've announced publicly in the last few months. The first one is material sensing. So we've partnered with an Israeli startup called Consumer Physics, and we've come out with a very small spectrometer, essentially. And what this does is it basically it senses any material. So food quality, so contaminated milk, for instance, is one of the use cases we're looking at. So it takes a spectrum of the milk, sends it up to the cloud, compares it to a database, and sends back down yes or no. So counterfeit pharmaceuticals, again, there's a huge number of applications here for this. And then the final slide, we made an announcement last week at a show in California, Santa Clara, with Microsoft and a company called Hexoskin, all around a smart vest, which in the first instance measures various vital signs from players. So one of the things managers will tell you is they don't know when to take players off to prevent injury and optimize performance. So the idea here would be that the heart rate, respiratory systems is is fed back to the coaching staff on the side, and they're able to make real-time decisions. Look at first responders. You could look at many other applications for this fest. So with that, thank you very much for your attention.